Today I'll explain the fifth unit. Fifth unit is having two parts. One is AC voltage controller, another one is cycloconverter. What do you mean by rectifier? Anyone? Which converts AC to DC. Inverter means DC to AC. But what is AC voltage controller? Which converts AC to AC. Chopper is DC to DC. But AC voltage controller is AC to AC. Input is AC. Output is also AC. Okay. Input is AC. Input AC is fixed. Output AC is variable. Just like the transformer, which converts AC to AC, AC voltage controller also converts AC to AC. Input AC is fixed. Output AC is variable. You want to get the variable output voltage. There are two types of AC voltage controller. One is single phase half wave AC voltage controller. Another one is full wave AC voltage controller. In AC voltage controller, if you see, let us see the full wave. See, in full wave, we are having two thyristors. So input is AC. Here they are showing only output AC. Input AC is fixed. That is sinusoidal voltage. Input AC is fixed. There is no firing angle at the input. For output, you will get the firing angle. Input AC is sinusoidal voltage. This is the input AC voltage, sinusoidal voltage. AC means we'll have both positive cycle and negative cycle. Now, during positive cycle, I'll give firing pulse to T1. During negative cycle, I'll give firing pulse to T2. How the thyristors are connected? Can anyone tell? How T1 and T2 are connected? Roll number 204. Can you tell how T1, T2 are connected? T204, unmute your mic and tell me how T1, T2 are connected. Who is 204? Akshita, no? Roll number 203. Unmute your mic and tell me. If you are not responding, I'll give option to you. At least tell me whether you know or not. Ankit Gupta. Hello. Akhilesh. Just you have kept the mobile on and you are going outside, or are you there in the meeting? Until you respond, I won't teach the class. Shashidhar. If no one is there, why I should take the class? If no one is responding, I'll wait for 2 minutes. If anybody responds, how the thyristors T1 and T2 are connected?
Anti-parallel, sir.
Anti-parallel. Okay. T1 and T2 are connected in anti-parallel. Now I am giving the firing pulse to T1. I am not switching on T2. Only T1 I am giving firing pulse. Let us take alpha is equal to 45 degrees or 60 degrees. I am giving the firing pulse to T1 at 60 degrees on x-axis. So T1 is on, T2 is open. We are not giving firing pulse to T2. Now current flows from, during positive cycle, this is the polarity at the input. Now current flows from negative to positive. Current always flows from anode to cathode, then through load, then again into source. So up to pi, T1 will be forward biased. So we can give firing pulse at 60 degrees during positive cycle. Now come to negative cycle. This is the negative cycle. From pi to 2 pi negative cycle. That means this polarity is changed. Once polarity is changed, negative is connected to T1. T1 is reverse biased. And T2 is forward biased. Why means negative is connected to cathode. That's why T2 is forward biased. Now I can give firing pulse to T2. At which point I am giving? At pi plus alpha I am giving. For T1 I am giving firing pulse at alpha. For T2 I am giving firing pulse at pi plus alpha. So from this point, from pi plus alpha, you'll get the output voltage. For T1, during positive cycle, from alpha onwards, I'll get output voltage. Take one straight line here. Take one straight line, and you'll get output voltage up to pi. After pi, both T1, T2 are off. From pi to pi plus alpha, T1 is automatically off here because T1 is reverse biased at pi because this polarity is changed. This is minus and this is plus. T1 is reverse biased. Even though T1, T2 is forward biased at pi, but I am not giving firing pulse to T2 at pi. So from pi to pi plus alpha, at pi plus alpha, I am giving firing pulse to T2. So from pi to pi plus alpha, both T1, T2 are open. That means load is disconnected from the source. So we are not getting the output voltage from pi to pi plus alpha. Again at 2 pi, the polarity is changed. Now it is plus, this is minus. Plus is connected to T1. We are giving firing pulse at 2 pi plus alpha. So from 2 pi to 2 pi plus alpha, both T1 and T2 are open. That's why load is disconnected from the source. Your load is resistance. There is no connection between the source and load. So we are not getting output voltage from 2 pi to 2 pi plus alpha. From 2 pi plus alpha onwards, I will get the output voltage like this. During the positive cycle, during negative cycle, T2 is on. T1 is on from here to here. From pi alpha to pi plus alpha to 2 pi, we'll get output voltage in the negative cycle. That means we are controlling both positive cycle and negative cycle. That's why it is called full wave AC voltage control. Is it clear? We are controlling both positive cycle. Here alpha, here also pi plus alpha, negative cycle, we are controlling. But see the half wave AC voltage controller. Half wave AC voltage controller. Here one thyristor is connected, but diode is connected. Diode will not have firing angle. Exactly at pi, diode is on. That's why you are getting full output voltage during negative cycle from pi to 2 pi. But during positive cycle, T1 is on. We are giving firing pulse at alpha. Alpha to pi will get output voltage. That means we are controlling only positive cycle here. We are not able to control negative cycle. Because diode is the uncontrolled element. Whatever the input will give, the same output will give from pi to 2 pi. But for thyristor can be only when firing is given, thyristor is on. But diode is all firing angle is always 0. Diode is not having any firing angle. Exactly at pi, diode is on because this polarity is changed. From pi to 2 pi, you'll get output voltage. But during positive cycle, we won't get output voltage from 0 to pi because we are giving firing pulse to T1 at alpha. From alpha to pi, you'll get output voltage. But there is controlling in the positive cycle. But there is no controlling in the negative cycle because diode is not having firing angle. Diode is an uncontrolled element. Thyristor is the controlled element. So we are getting output voltage up like this in the half wave AC. Why it is called half wave AC voltage controller? Anyone? Why it is called half wave AC voltage controller? Why not full wave? Can anyone tell me why it is not full wave AC voltage controller? Because we are controlling only positive half cycle. We are not able to control output voltage in the negative cycle. We are getting the complete negative cycle as output voltage because there is no firing here. Input is AC, output is also ACC here. We are getting both positive and negative cycle. But positive cycle is controllable, negative cycle is not controllable. Okay. Since it is the resistance exactly at alpha, we are getting the current also like this. If there is inductance, current will be delayed. But here there is no delay in the current. Exactly at alpha, current is rising like this. Okay. And now see the full wave AC voltage controller. The difference you observe. Here there are two thyristors. Both are controllable. Positive cycle and negative cycle. But in half wave, you see, one in the negative cycle, diode is on. In the positive cycle, T1 is on. There is no controlling in the negative cycle. Whatever the input you are giving, same output you are getting in the negative cycle. But in the positive cycle, this is the input complete from 0 to pi. But output is from alpha to pi m. They have not drawn the input voltage. Sinusoidal voltage is the input voltage, AC voltage. And this is the controlled voltage. We are controlling the output voltage by varying the firing angle. Exactly at alpha, current is rising. This is I naught, this is V naught. V naught is the output voltage, I naught is the current. Is it okay? Can anyone explain this half wave AC voltage controller? Go through this half wave AC voltage controller for 1 minute. I will call anyone. They have to explain me. I will call any roll number. If you say, I will give the attendance. If you are not explaining, I will mark it as absent. Your attendance. You have to explain first positive cycle from 0 to pi, then negative cycle from pi to 2 pi. Roll number 202, unmute your mic and explain the half wave AC voltage controller. Roll number 202. '22 series 202. I'm marking it as absent for you. Roll number 201, 23 series 201. Absent? Okay. 23 series 203. Unmute your mic. Unmute your mic. '23 series 203. I'm marking as absent for you also. 23 series 204. Who is 204? Not there. 207. Who is 207? 23 series. 22 series 236. Are you there? Not there. Okay. 208. 208. Roll number 210. You
Sir.
don't want to respond? Roll number 210.
Sir, present.
Explain me about the single phase half wave AC voltage controller. You can tell me, I will assist you if there is any doubt.
The circuit is in single phase half wave AC controller, sir, where the thyristor will be controlling the positive half cycle and reaches the load.
During positive cycle, since polarity is like this for the input from 0 to pi, positive is
Yeah.
connected to anode, thyristor is forward bias. Since positive is connected to cathode, diode is reverse bias. So once
Yes.
T1 is forward bias, current flows from negative to positive, from anode to cathode, then load, then again into source. So
Yes.
from alpha onwards, you will get output voltage up to pi. Now
Yes.
explain the negative cycle.
Diode allows the conduction to the negative half cycle, sir.
At pi, exactly at pi, diode is on. Y means
Yeah.
this polarity is changed, negative cycle. Negative is connected to cathode. Since there is no firing angle, exactly from pi to 2 pi, diode will be on. Again at 2 pi, diode is off.
It
T1.
adjusts the yeah. It
So
adjusts the
diode,
firing angle. Then the power will be delivered to the load.
okay. So from pi to 2 pi, you'll get the output voltage. But here during positive cycle, from alpha to pi, you'll get the output voltage. Again during positive cycle, 2 pi
Yes.
plus alpha. Okay. Okay. Done. Next. 23 series, roll number 212. Roll number 212. Pranav.
Yes, sir.
Can you explain me the full wave? Is 1 minute. Full wave AC voltage controller. Explain positive cycle what will happen, negative cycle at what point thyristors are on.
So from 0 to alpha, the input Vs is positive. The thyristor T1 is off. Therefore, the output voltage is 0.
Thyristor is forward biased, but off. Okay. Where you are giving firing pulse to T1?
We are giving at pi, sir.
At alpha, we are giving firing pulse
At
to
alpha,
T1.
alpha.
Okay, at alpha, we are giving firing pulse to T1. Once T1 is on, load is connected to source. T2 is off, only T1 is on. Now there is connection between load and source. Current flows from source, T1, then load again into source. Up to pi, we are getting output voltage like this. This is the output voltage from alpha to pi. So at pi,
Yes, sir.
T1 is off, reverse bias, because polarity is changed. At pi, we are not, T2 is forward biased, T1 is reverse biased, but I am not giving firing pulse to T2 at pi. We are giving firing pulse to T2 at pi plus, where we are giving pi plus
Pi plus alpha.
alpha. So from pi plus alpha onwards, we will get the output voltage. Take one straight line here. Take one straight line, and this is the output voltage up to 2 pi. At 2 pi, T2 is reverse biased again, T1 is forward biased. It is entering into the positive cycle. So from 2 pi to 2 pi plus alpha, both T1, T2 are open. From pi to pi plus alpha also, T1, T2 are open. There is no connection. That's why you are not getting the output voltage. From pi to pi plus alpha, 2 pi to 2 pi plus alpha. At 0 to alpha also, we are not getting the output voltage. So this is for the resistance. Okay, this is the full wave rectifier. Okay. I have shown the load is resistance. Now see the remaining waveforms also. So the same circuit I am showing here, single phase full wave rectifier, sorry, not rectifier, AC voltage controller. T1, T2 are connected in anti-parallel. VT1 is the voltage across the thyristor, VT2 is the voltage across the thyristor 2. Now this is the input voltage. See here, they have given the input voltage. In the previous circuit, in the previous waveform, they have not shown the input, but here they are showing the input voltage. This is the input. Vs is the source voltage. Vs is the source voltage like this. Now Ig1 is the firing pulse to thyristor 1, gate current. Ig2 is the firing pulse to thyristor 2. At alpha, I am giving firing pulse to T1 during positive cycle. During negative cycle, I am giving firing pulse to T2. Again during positive cycle, T1. Again during negative cycle, T2. Since your load is R, exactly at alpha, I am getting the output voltage. Up to where? Up to pi. Up to pi, I'll get the output voltage. From pi to pi plus alpha, I won't get any output voltage. Exactly at pi, T1 is open, reverse bias, because it is entering, polarity is changed. But T2 is forward biased at pi. Even though it is forward bias, I am not giving firing pulse at pi. Where I am giving firing pulse? At pi plus alpha. So from pi plus alpha onwards, correct, we will get output voltage. Why in the negative cycle we are getting output voltage? When T1 is on, we are getting positive. But when T2 is on, negative. Why means, see here, when T1 is on, current is flowing in the load in the downward direction. Now when T2 is on, current is flowing from this polarity is changed, negative to positive like this. Current is flowing in the upward direction in the load. Then again T2, then into source. T1 on ఉన్నప్పుడు current flows from in the load in the downward direction. If T2 is on, current is flowing in the reverse direction in the load. Polarity is changed in the load. That's why output voltage you are getting in the negative cycle. Input is AC. Here see output is also AC, positive and negative. Here also positive and negative. But when firing is given, then only you'll get the output voltage. In positive cycle at alpha, I am giving negative cycle pi plus alpha. Again, positive cycle 2 pi plus alpha, 3 pi plus alpha, 4 pi plus alpha, 5 pi plus alpha. Like this, we'll get the output voltage. Current is also exactly at alpha, current is rising. Why means it is the resistive load. And thyristor voltage VT1 and VT2. During positive cycle, T1 is forward bias. So from 0 to alpha, thyristor is open. In open circuit, you'll have the voltage. So up to alpha, I'm getting the output voltage. So T1 is forward biased, but the same positive voltage appears as reverse voltage, reverse bias T2. That's why take one mirror and place it and draw VT2, thyristor voltage. When thyristor is on, voltage in thyristor is 0 and current is flowing. Current will increase. So in parallel, once it is short circuited, this is also short circuited. Voltage is 0 in short circuit. In the negative cycle, the reverse voltage appears across T1, but same voltage will appear as forward voltage. In the negative cycle, voltage across thyristor T2 is forward, but T1 is reverse biased. So this is during negative cycle. Again during positive cycle, exactly opposite T1 and T2 because they are in anti-parallel. This is for the resistive load. Okay. Now see for the RL load, how we'll get for the RL load. See, this is the input voltage and gate pulse I am giving at alpha during for T1 at pi plus alpha for T2. Since we are using the RL load due to inductance, current is not immediately rising here. Current is taking some time to increase. At up to pi, current will increase. After pi, current will not immediately come to 0. Current is slowly decaying to 0 in the load at beta. Before you give firing pulse, current is decaying to 0. So up to beta, we'll get the output voltage. Up to beta, we'll get the output voltage. But for resistive load, you see, up to pi only you are getting output voltage. But in RL load, current is decay. Beta is called extinction angle. Current is coming to 0 at beta. So up to beta, we are having current in the load. Current multiplied by impedance is V0. So up to beta, I will get output voltage. From beta to pi plus alpha, I won't get the output voltage. Why means after beta, current in the load is 0. V0 is equal to I0 into Z. And there is disconnection in the load because T1, T2 both are open from beta to pi plus alpha. From beta to pi plus alpha, both are open. That's why you are not getting the output voltage. And thyristor voltage, see here at alpha I am giving firing pulse. So at alpha I am giving firing pulse. Otherwise we take pi plus alpha. From beta to pi plus alpha, voltage across thyristor T2 is negative, T1 is negative and T2 is positive. So we are getting the thyristor voltage like this. But during positive cycle from this beta to pi plus alpha. See, this is the current is also AC here. See, current is also AC. So this is for the RL load. This is the discontinuous conduction because current is coming to 0. After current coming to 0, you are giving firing pulse. Suppose if you give firing pulse before beta, this current will not come to 0. If you give the firing pulse to T2 before beta here, this current will not come to 0. Again, current will increase up to pi plus, up to 2 pi plus alpha. So any doubt in the RL load? RL load current is delayed, but in the resistive load current is not delayed. Exactly at alpha current is increasing, exactly at pi current is coming to 0. Exactly at pi plus alpha current is increasing. But in RL load it is not the case. Current increases up to pi. After pi immediately current will not come to 0. It will take some time in the load current to decay to 0 because of the presence of inductance. So up to beta we will get the output voltage. From beta to pi plus alpha, we want to get any output voltage. From beta to pi plus alpha. Again at pi plus alpha, I will get the output voltage. Up to 2 pi plus, up to beta. This is beta. Not up to 2 pi. We are not getting output voltage not only up to 2 pi. Up to 2 pi plus beta. This is beta. When current comes to 0, take one straight line here. So this is 2 pi. From 2 pi to up to this beta. I had already told you to extend one backward line so that we will get this is the output voltage. If you extend the backward line. If you're hanged out, you can ask me. Go through this circuit, RL load for 2 minutes.
Sir, in Vout, why there is output voltage before alpha?
Which one?
Vout, waveform.
V naught. Before
Yes, sir.
alpha. Okay. Before alpha, you see here. Let us take second cycle. This is the up to beta. Up to beta, you
Yes,
are
sir.
getting output voltage or not.
Yes.
So up to beta, take one straight line here. Extend one straight line upwards like this. So up to this is the beta. This is 2 pi plus alpha. So that means we are getting this output voltage like this. Extend one backward line here like this. Here also you see extend this backward line. So here up to here we'll get the output voltage.
Okay, sir.
Okay. So this is about the AC voltage controller for resistive load and RL load. So you write this as the assignment in your notes. For R load, this slide, and RL load. Only for full wave AC voltage controller. Full wave AC voltage